Okay, this is another question on convolution. We have x of t, which is a rectangular pulse, and h of t is an exponential function. So in all of these cases, because now my h of t is not flat, it's an exponential, and when we shift it, uh, it will change the function. So if this function is e raised to the power minus t, this is e raised to minus t. If we shift it in any of these directions, then this will be e raised to the power minus t minus a. So we don't want that. We want that the function, we try to have h of t such that it's a flat function. If there is no choice, then we have to do it. But in this case, we can exchange these two. So we can bring this here, and we can bring this here. So in that case, uh, the convolution will be so. And why we can do it? Because x of t convolution with h of t is equal to h of t convolution with x of t. So we can exchange the two. So in this case, what we will do here is we will so in this case, what we will do here is we will uh, make this our x of t, and this will be h of t, and then we start the applying the convolution. So the first step is to change the axes as we did before. So this will become x of tau, and this will become h of minus tau. So here minus 2 minus 3, and this is tau, and the reference point is minus 2, and the shift will be from this reference point. So all the shifts in towards left will be negative, and towards right will be positive. In this case, we will be just shifting towards right, so all the shifts will be positive. So case 1, we will shift it until the rectangular pulse is here, and then it starts coming inside, and then it is completely inside, and then it will be just completely inside uh, in this towards this direction when it passes this time. So case 1, so there will be 3 cases. Case 1, which is completely outside; case 2, partially inside; case 3, completely inside. So let us start with the case 1, which is outside. So I can draw my x of t tau, and this is my reference minus 2, and this is the last time at which the h of t remains outside. So this is how much is this time? This time is minus 2. plus 2. So we can write that case 1 is the case which is when the shift is less than or equal to 2 and there is no overlap. So my y of t, which is equal to minus infinity plus infinity x of tau h of t minus tau d tau, that will be equal to 0. Now let us move to the case 2, which is h of t minus tau partially inside. In this case, I have my reference, minus 2 is my reference point, and this is my x of tau, and my rectangular pulse is coming inside partially. So this is my overlap. This is the overlap. This is 0. This is tau axis, and this is x. So now what is x? We know that this is t, the shift from the reference. So x minus x plus 2 equal to t. This implies x is equal to t minus 2. Now this will remain. What is the time limit for this? It will be greater than 2 but less than 3, because so it will be greater than 2, but less than 3, because the width of this pulse is 3. So what is the end of this case? The end of this case, we can draw it here, so we know that what will be the end. The end is when the pulse comes completely inside. So this is 0 and this is 2, and from the reference, so this is 0 and this is 1, and from the reference this point is, the shift t is 3. So this is the end of case. So now let us compute this integral. So y of t will be equal to 0 to x, and x is t minus 2, and the function here is e raised to the power minus tau d tau, and once we integrate it, the answer will be minus e raised to the power minus tau integral from 0 to t plus 2, and that will be equal to this is negative, so 1 minus e raised to the power minus tau t minus 2. Okay, now the last case, case 3. H of t minus tau is completely inside. So I can draw my x of tau, and this is my, so this is x and this is x minus 1, and this is my overlap, and this time is all the time which is greater than 3. So this is t is greater than equal to 3. So y of t in this case is just an integral between x minus 1 and x e raised to the power minus tau d tau. So that will be minus e raised to the power minus tau x minus 1. Now in this case this is my reference. So again x plus 2 equal to t and x equal to t minus 2. So it will be t minus 3 to t minus 2, and that will be, this is a negative sign, so I will put this first, minus t minus 3 minus e raised to the power minus t minus 2. Now there is a check that at the intersection point, at the overlap, the point of overlap, which is 3 in this case, both of them should give me the same equation. So at t equal to 3, from case 2, the answer is e raised to the power, y of t is e raised to the power minus t minus 2. So y of t equal to 1 minus e raised to the power minus 1, and from case 3 it will be y of t will be equal to 3 minus 3, 1 minus e raised to the power minus 1. So means that our answer is okay. So now I can draw my y of t. Y of t is 0 until 2, until 2 it is 0, and between 2 to 3 it is 1 minus e raised to the power minus t minus 2. So it goes up until 3. At 3 it is 1 minus, so y of 3 is equal to 1 minus e raised to the power minus 1, which is equal to 0.632. And then if you just put some of these numbers, 4, 5, you will see that this function starts coming down, and at little bit after 5 it becomes almost 0. So this point is 0.63. Okay.